Hello there and welcome to October 2020 paper 1. Here we're looking at question 4. The plane pi1 has equation 2i plus 4j minus k plus lambda lots of I plus 2j minus 3k plus mu lots of minus 1 plus 2j plus k. Now the first thing I'm going to do here before even reading the question is write this in my favourite vector form, which is 2, 4 minus 1 plus lambda lots of 1, 2 minus 3 plus mu lots of minus 1, 2, 1. Much better. Where lambda and mu are scalar parameters, find a Cartesian equation for pi1. So that is n1x plus n2y plus n3z equals d. That's what a Cartesian equation for a plane is looks like. Now, so let's work out how to do this. So what we've got here is we've got a plane. We've got a point on the plane that's 2, 4, minus 1. This is our n vector. That's the n1, n2, and n3 part. And we've got two vectors that are on the plane. We've got this vector here, and we've got this vector here, where both of these vectors are at a right angle to the n vector. That's what the n vector is. It's the normal vector. It's normal to the whole plane. Every single vector on the plane, it's normal to it. So what we're going to do is we're going to start first by setting up our n vector just to make things easier. So n1, n2 and a 1 on the bottom, and if I get any fractions on n1 and n2 then I'm just going to scale factor them up, scale factor the whole direction vector up so there's no fractions. So just to make things easier for me, I'm going to put a 1 on the z dimension there. Now the bit of maths I now have to use is the dot product rule with these two vectors here, because I have two vectors that are going to be at a right angle to each other, and we know that when we have two vectors that are at a right angle to each other, we can use the dot product rule, and the dot product rule will equal 0 because cos of 90 is 0. So it's going to be n1, n2, 1, dotted with 1, 2, minus 3. We're only going to dot it with the direction vectors because it's only the direction vectors that are going to be perpendicular to the normal vector. This first bit here is just a starting coordinate. It's not a vector really. So let's expand the brackets. This thing will equal 0 because it's at a right angle, so therefore it's n1 plus 2 lots of n2 minus 3. So I'm going to just move the 3 onto the other side there. And onto the second one, it's going to be n1, n2, 1, dotted with minus 1, 2, 1 equals 0. So I'll write this is equal to minus n1, minus n1 plus 2n2 equals, now this would be 1, so when I move it on the other side, it would be minus 1. So now we've got two equations. Let's solve them, equation 1 and equation 2. So let's add the two equations together to cancel out n1. So that's going to give us 4n2 equals 2. So therefore n2 will equal a half, which is fine. And then if we plug it back into equation number 1, we're going to get n1 plus 1 equals 3. So therefore n1 will equal 2. So therefore, I'll start working down this little column here now. So therefore the n vector is going to be equal to a half. So no, not half first. It's n1 that goes first. So it's 2, then a half, then 1. Now we can always scale factor up a direction vector. So it's going to be 4, 1, 2. So therefore that is the simplest integer direction vector for the normal vector. So therefore n1 is 4, n2 is 1, and n3 is 2. Now we just need to work out what the d is equal to. So let's write it out. 4x plus y plus 2z equals d. Now what this x, y and z refer to are coordinates that are on the plane. Should multiply by a 4, a 1, a 2 and make this d value here. So to work out what the d value is, let's take a coordinate that we know is on the plane, this coordinate here, 2, 4, minus 1, and substitute it in. So it's going to be 4 times 2, add another 4, add 2 times minus 1 equals the d value, and the d value is going to be 8 plus 4 is 12, minus another 2, that would be 10. So therefore your final answer for part A is going to be 4x plus y plus 2z equals 10. And there we are, that's the answer for part A. Let's move on to part B then, so let's just make a note of that in the top right. 4x plus y plus 2z equals 10. Okay, so part L, so the line L has the equation of this thing here. Now before I move on, again I'm going to write equation L in my preferred form. So it's going to be 1, 3 minus 2 plus lambda lots of 5 minus 3, 4. Find the coordinates of the point of intersection with the line L and pi 1. Okay, so what I'm going to do here is I'm going to combine my two vectors here, my position vector and my direction vector. So we could effectively think of r as 1 plus 5 lambda, 3 minus 3 lambda, and minus 2 plus 4 lambda. Okay, so the top row, that's the x value. So the middle row, that's the y value, and the bottom row, that's the z value. And now I'm going to take this x, y, and z set of values and plug it into this plane up here. So it's going to be 4 times 1 plus 5 lambda. Effectively, I'm doing a substitution, a solving equation by a substitution, effectively, substituting the line into the plane, plus 3 minus 3 lambda, and then plus 2 lots of minus 2 plus 4 lambda equals 10. So let's work out what lambda needs to equal. It's going to be 4 plus 20 lambda plus 3 minus 3 lambda minus 4 plus 8 lambda equals 10. Okay, let's now just rearrange a little bit. So it's going to be 28, 25 lambda equals, and then moving all the numbers onto the right hand side, the 4 and the minus 4 will cancel out, just be moving the 3 onto the other side, so that would be 7. So lambda is equal to 7 over 25. And now all I need to do with this value of lambda here is plug it back into the equation of the line. So therefore the coordinate is going to be 1 plus 5 lots of this 7 over 25. I'll just grab my calculator. And so it's going to be 12 over 5 on the first coordinate, 12 over 5. The second coordinate is going to be 54 over 25. And the third coordinate is going to be minus 22 over 25. And there we are, that's the answer for part B. That's the point at which the line intersects the plane. Let's now move on to part C. So just a reminder, it was 4x plus y plus 2z equals 10. That was the equation of plane 1. Moving on to the second plane now, that's r dot 2i minus j plus 3k equals 5. Find to the nearest degree the acute angle between pi 1 and pi 2. So let's visualize a diagram here. What I'm going to do now is draw out my planes, but I'm looking down the planes. So I can see the angle that I want to find here. That's the angle between the two planes. Now if we call this plane 1 and this one plane 2, then what we do have is the normal vectors of both the two planes. For plane 1, that normal vector is 4, 1, 2. For plane 2, that normal vector is 2, minus 1, 3. And what we can therefore do is work out the angle between these two planes. Know that there's two right angles here, so then all we need to do is then 180, because it's 360 inside a quadrilateral, but we've got two right angles, so it's take away 180. So it's 180 left between these two angles here. So work out this angle here, and then work out this angle down here afterwards. So, well, in fact, it could be this angle here also. So, don't really need to minus 180 from it, but we can. I like to help. Like this diagram, I like to use to help visualize that I'm taking 180 away because I'm working out the dot product between the two lines, and therefore doing 180 minus it will get the angle between the two planes. and it's to the nearest degree. So let's use the dot product rule. It's going to be 4, 1, 2, dotted with 2 minus 1, 3, equals the modulus of 4 squared plus 1 squared plus 2 squared times 2 squared plus 1 squared times 3 squared, no, plus 3 squared, cos theta. So the dot product here is going to be 8 minus 1 plus 6, and then we'll divide by these square roots now. So it's going to be the square root of 16, 17, 21 times square root of 4 plus 1 is 5 plus 9 is 14 equals cos theta. So let's now do cos inverse of this value here to the nearest degree, and that will give us theta equals 41 degrees. Theta equals 41 degrees. So if we do 180, we'll get this angle here, but then if we do 180 again, we'll get this angle here. So basically this angle that's up here is exactly equal to this angle down here. So we could say therefore that the angle between the two planes in this position here is 41 degrees. But if you want to do the 180 minus it, 180 minus answer, you could also use 139 degrees, but it does clearly say the nearest acute angle, so therefore ignore that one, this one's the acute one. So there we are, that's the answer for this question here then. Question 4, the vectors question for this paper, worth 9 marks in total. Let's now move on to question 5.